This video will show you the block structure of the periodic table. We're all familiar with the periodic table by now. You've probably noticed, we've got these clusters of columns that are all the same size. What does that mean? We call the first two columns the S block. So these are the alkaline metals and the alkali earths. Here, n can equal 1 or more, so we have n equals 1, n equals 2, n equals 3. To get an s orbital, L must equal 0. If L equals 0, m has to equal 0. There's only one possible value of m, therefore the s block, or an s orbital, contains only one suborbital. Looks like this, it's spherical. Spin can be plus or minus 1/2. It has two possible values, so there can be 2 electrons in this suborbital. So we've got 2 columns for those 2 electrons. Next, we look at the p block. P block is named for the p orbital. Those can appear if n is 2 or greater, because L has to equal 1 for a p orbital. If L equals 1, m can be -1, 0, or +1. 3 possible values means that there are 3 suborbitals in the p orbital, and you can see them here. You've got 1, 2, 3, all come together. Each of those suborbitals can hold 2 electrons according to the spin number, so the p orbital in total can hold 6 electrons. You can see we've got 6 columns here. If we continue going up in value, we got the d block next. L has to equal 2 to have a d orbital, so n is 3 or more. If L equals 2, m can be -2 to +2, so the d orbital contains 5 suborbitals. You can see them here, 1, 2, 3, 4, 5. Each of those suborbitals can hold 2 electrons, so it contains 10 electrons in total. And you can see we've got 10 columns. That matches up with those 10 electrons. If we keep going, we have the F block here at the bottom, the lanthanides and the actinides. L equals 3 for an F orbital, so n must be 4+. M can be -3 to +3. 7 values means there are 7 suborbitals, as you can see here. Each suborbital can hold 2 electrons, so this suborbital, or all of these suborbitals contain 14 electrons in total. And to fill in an electron configuration, you would start up at hydrogen and then just work your way across the rows and down the periodic table like so. And remember, when it comes to filling them in, the periodic table should more properly look like this, with the F block placed between the S and the D blocks. So if you were working on a very heavy element, you could start at, say, 6s, this is the 6s, then you would fill electrons into the 4f, then the 5d, then the 6p. If you still need some help working with electron configurations, check out the other video that's posted today.